Good morning, ladies and gentlemen. My name is Rangga from Pertamina IP. Today, I would like to present our study, Biogenic gas in North Sumatra Basin, Underexplored gas potential in mature basin, created by me, Rangga Perdana Putra, Muhammad Jauhari, Wahyu Wibowo, Amin Bunyamin, Asri Surya Ilhami, Adrinal Ilyas, and Fuad Nuri, all from Pertamina IP. North Sumatra Basin is a major basin that has been known as a prolific oil and gas producer since 1885. Gas accumulation at a relatively shallow depth often been found while drilling on this area. One of those gases that can accumulate at shallow depth is biogenic gas. However, the presence of this biogenic gas is more considered as a hazard than a potential. The object of this study are to answer the following question. One, does biogenic gas exist in North Sumatra Basin? And two, how much gas can we expect? From previous research, there are certain characteristics of biogenic gas that has been known, such as it produced during the decomposition of organic matter by microorganisms, generate from anoxic paleo environment or sulfate deficient environment, have light isotope, consists more than a 55% methane gas, generate from high rate sedimentation and low geothermal gradient. Uh, on the figure 1, we can see the location map of the study, including Rantau, Aru, and Langkat area in North Sumatra Basin. And on figure 2, we can see the North Sumatra stratigraphic column, modified from Riyadi et al. 1998. We can see at the shallow depth, we can find Julurayu Formation, Serula Formation, and Ketapang Formation. Ketapang Formation is the formation that we will need to know more, because on this area Ketapang is widely found in this area. We move to data and method. There were total 35 well data that been used in this study. 14 well have vitrinite refractant data and TOC data. 20 well have gas chromatograph data, but unfortunately none of them have isotope data. In order to know the biogenic gas speculative resources, three aspects that need to be considered. There are geology analysis, geophysics analysis, and geochemistry analysis. On the geology analysis, formation depth, age, bottom hole temperature are needed to create a sedimentation rate map and a thermal gradient map. Then heating rate can be calculated by multiplying them. It gives a first overview of the biogenic gas generation potential from Snyder et al. 2016. After we know the heating rate map, we can also add seismic attribute data to found the potential area of the generation of biogenic gas, of this biogenic gas. And then from geochemistry data, we can create a calculated TOC log. And the next step is calculating the speculative resources using max methane yield. So we move to research and discussion. On the figure 4, we can find sedimentation rate map. Sedimentation rate in North Sumatra Basin is ranging from 78.9 to 282. The lowest sedimentation rate is on Belucut well, and the highest sedimentation rate is on Batumandi 1 well, Batumandi 1 well. Area around Telaga site and Sekundur do not have sedimentation rate data because Ketapang formation were outcrop on that area. On figure 5, we can see the thermal gradient map. The thermal gradient in North Sumatra Basin is ranging from 12 to 69. The lowest thermal gradient is on Wampu, and the highest is on Pantai Pakam Timur. On figure 6, we can see the heating rate map. Heating rate in North Sumatra Basin is ranging from 1.77 to 16.4. The lowest heating rate is on Palu Tabuan Timur, and the highest is on Pantai Pakam Timur well. So, based on its heating rate, a potential area can be classified into 3 categories. Unlikely, 7 to 9 with green color, and then probable area, 9 to 12 with yellow color, and highly probable 12 to 18 with red color, using this classification from Snyder 2016 and methane max yield plot that I will be explained later. The biogenic gas potential can be calculated. After we know the heating rate map, we double check the geophysics analysis using sweetness attribute and section. But unfortunately, we only have 2 3D set data, one in Aru area and one in Langkat area. From this data, we have some bright spot found at the section, at the seismic section. Bright spot amplitude anomalies would be reliable DHI for gas reservoir in this area and proved to be associated with any oil and gas or gasio. But it could also be associated with thin stack reservoir due to tuning thickness effect. And at the figure 8, we can see the example of TOC calculation and max methane yield from each area. Ketapang Formation is not a thermogenic source rock, so we lack of TOC data, geochemistry data on this formation. We only have the data from lower bound interval. So we use electronic log from resistivity to create a calculated TOC log data using a PASI method. And then after we know the calculated TOC, we can use cut off 1% TOC to know the net pay of this formation. And after that, we use the choker plot from choker 2012 to know the max methane yield of this area. And we can see on the right side of this figure, there are 4 areas that are very interesting, has interesting data. 1 is from Rantau Kuala Simpang, 2 is from Serang and Pulau Panjang, 3 is Pantai Pakam Timur, and 4 is Batu Mandi. And the max methane yield from each area can be seen in this figure. So we move to conclusion. The first conclusion is, hypothetically, there is a good chance of biogenic gas accumulation in the shallower part of North Sumatra Basin, with max methane yield is approximately 2.1 TCF. This only calculated from the probable case. And the second one, Knowing this huge biogenic gas potential, shale gas should be considered more as a potential future play than just a hazard. And then acknowledgement, the author appreciates the support from Sumatra Exploration Team in this paper project, and also acknowledge Exploration Division PT Pertamina EP Management who granted permission to publish this paper. References, this is uh, all the references that been used in this study from Barker and Fritz, Choker, Horner, Katz, Pesci, Rice and Claypool, Snyder, and Shaw. I think that's all. Thank you for your attention.